In today's video I'm going to show you how to use completing the square method for solving the quadratic equations. Before I start, I would like to show you the solution of this quadratic equation: x squared plus 6x plus 9 equals 0 by using the factoring method. We already know that we are looking for a pair of numbers which add up to 6, and the same pair of numbers, when multiplied, the product will be 9. So I think everybody sees that my numbers are 3 and 3. So this expression on the left side of this equation can be written as multiplication of two factors: x plus 3 times x plus 3 equals 0. This expression on the left side can be simplified so that x plus 3 squared equals 0. We were using the method of taking the square roots of both sides of this equation, and it will come to absolute value x plus 3 equals 0. And we now know, and I think everybody can see, that the only solution of this equation is x equal to -3. But what is most important in this example is becoming from this expression to this one. And by the way, expression x plus 3 squared is called perfect square. So till now we were able, and we were solving mainly quadratic equations which could be solved by this method. But let's have a look on the equation x squared plus 6x plus 7 is equal to 0. Now the question is, if you are able to find pair of numbers which add up to 6, and if we multiply them, the product will be 7. After a while you'll become to the conclusion that it's not so easy, because there are no such two integers or natural numbers, or let's say rational numbers. So my question now is, how can we reorder or use this equation connected to the expression on the left side of our first equation and get the advantage of the equation on the left side? Yes, x squared plus 6x equals -7. So we took away -7 from both sides of our first equation. Why did we do so? And the answer is very simple, because now we can come on the left side with the expression which is approximately or the same expression as we are solving here, and we will use the advantage of the perfect square we will get. So what are we supposed to do with the expression on the left side of this equation? So there is only one way, and we can add number 9 to the both sides of this equation. So my equation is now in this form, and if we think about it and use the perfect square, we can rewrite the left side expression being x plus 3 squared equals 2. And this is something we are able to solve, because we can do the square root of both sides of this equation, and we will get x plus 3 in absolute value equals square root of 2. Square root of 2 is not a very nice number, but it's still number, and it's still valid number, and I'll show you why. So now we are able to solve this equation by x plus 3 equals plus minus square root of 2. So the first root for my equation is x1 equals -3 plus square root of 2, and the second root x2 equals -3 minus square root of 2. My next question is, how can we quickly check, but it's not like the real check and it's not enough to be clear that both these roots are the solution of my first equation or of my given equation. But I still can do this kind of check when I multiply these two numbers, like my roots, minus 3 plus square root of 2 times minus 3 minus square root of 2. What am I expecting? What will be the product of this multiplication? For those of you who said it's gonna be number 7, you are right. For those of you who don't see this number behind this multiplication, I'll explain. So basically we multiply like first with the first and first with the second and so on with the second term in the first expression. So it's like negative 3 squared plus 3 times square root of 2 minus 3 times square root of 2 minus, and now I will write it like square root of 2 squared equals negative 9 squared. The negative 3 squared is 9, and as you can see these middle terms will cancel each other, so it becomes 0, and now we take away, and square root of 2 squared is equal to, and this gives me number 7. So this was a quick check for the solution, very quick check, but not the proper one, because we have to do like proper check. We have to calculate the value of the left side of our equation, and let's take negative 3 plus square root of 2. So it means negative 3 plus square root of 2 squared plus 6 times negative 3 plus square root of 2 plus 7. We can write this expression like minus 3 plus square root of 2 times minus 3 plus square root of 2, because we are not able to calculate this like properly, as you will see later on. This is good manner, this is good thing to do. Plus, it's gonna be minus 6 times negative 3 is negative 18 plus 6 times square root of 2 plus 7. So we do the multiplication here. Negative 3 times negative 3 is 9. Negative 3 times square root of 2 is negative 3 times square root of 2. The same applies for the rest. And we already know that square root of 2 times square root of 2 is equal to, so plus 2 minus 18 plus 6 times square root of 2 plus 7. We are happy now because I think everybody can see that negative 3 of square root of 2 will be cancelled with 6 times square root of 2. So my result is now 9 plus 2 minus 18 plus 7. Good news, 11 minus 18 plus 7 equals 0. The right side of the equation for negative 3 plus square root of 2 is 0. My conclusion here is left side equals right side. So I'm happy with this root. And if you would apply the same check for the second root, you will get the same result, and I wish you'll try it by your own. Thanks for watching. Good luck with math.